Okay, Assalamualaikum warahmatullahi wabarakatuh and good day everyone. So today we will continue a new chapter and also the last chapter for this subject, which is we go to the analysis function. Okay, so basically what I explained in the lecture notes. Okay, so I will brief you about some exercise that we can do in the chapter analysis so that you can understand more about this analysis function. So I will show you about a simple example. Okay, simple example on how analysis function. So we start on the new part. Okay, we start on the new part here. And we go to the sketch. We just do a simple beam truss. Okay, just a simple beam in order you to show you can draw it. Okay, say this is 80, this is 30, this is 25, also this is a 25. Okay, so we give a smart dimension here. Just a simple beam trusses. This is a 30, this is a 80. So make it equally. This is a okay. So this is a simple beam trusses, and after that you exit the sketch and do the extruded. Okay. For example, this is a 50 mm. Okay, so this is the simple beam trusses that you can analyze. Okay, if you have any solid work part, okay, the part design, you can analyze it. Okay, how you want to start doing the analyze? Okay, so first thing you need to activate activate the analysis function here. So how you want to activate? So you have go to the top of the toolbar here that you have a gear icon. You can click it and then you go to the sorry. Okay. You can click on the left side. So you can go to the simulation. Okay, so you can go, you click on the beside the icon of the gear, okay, and then you can add ins. Okay, you can add ins. So in the add-ins, you can activate the features that you already installed in the SolidWorks simulation. So if the SolidWorks simulation doesn't tick, you need to tick in order to activate the SolidWorks simulation. So you can basically you can if you need to use this function usually, okay, you can tick at the startup. Okay, just click OK. And then at the tab here, it will activate the simulation function. Okay, it will activate the simulation. So when you click on the simulation here, okay, so this is a function on the simulation. So you have a new study here: apply material, simulation evaluator, fixtures, advisor, external load, connectors. Okay, so this is function that you can use in the simulation. So first thing first, you need to create a new study. Okay, create a new study. Just click on this and click on the new study. Okay, and in this study, okay, so you have several function or several analysis that you can use. The first one is a static analysis. So this is a linear static that I will show you next for this example. And then we have a frequency. So if you want to analyze the frequency response for this part, you can use this frequency. And then we have a function of the topology optimization study, design study, okay, in order to optimize the weight or the structure of this part. And then we have an advanced simulation, okay. Advanced simulation, we have a thermal analysis, buckling analysis, fatigue, nonlinear, and also linear dynamic. And specialized simulation, we have a drop test and pressure vessel design, okay. So this is a several type of the analysis that have in the SolidWorks. So basically in this subject, I will show you about only the static analysis and also maybe about the flow analysis or the thermal analysis. Okay, uh, I'm not show you about all the advanced simulation, buckling, fatigue, nonlinear. If you want to study more regarding on this analysis, you can try to um, find on the YouTube or another source. Okay, so basically for this simple structure, I choose the static analysis. So you can, okay, you can name it. For example, in static. Okay, okay. When you name it as this study, you can click OK. So after that, it will activate all the function in the simulation tab. Okay, so first thing first is apply material, simulation evaluator, fixtures, advisor, external load, connector, shell, run. Okay, and you can run. Okay, basically uh, in the tree on the left side. Okay, so this is a function that you need to fill up. Okay, the first thing is a part. Okay, this is a part, and then you need to apply the connection. Okay, apply the connection if you have some connection to do. If you don't have any connection that you need to apply on this part, you can ignore it. And then we have a fixtures. So fixtures is basically about the fixed part. Okay, and then you need to apply the loads and then remesh it and mesh. Okay, meshing. Okay, meshing elements. And also we run the analysis and we need to see the result. Okay, so the result is that we need to see is the stress analysis, stress result, displacement, um, and also the factor of safety. Okay, so first you need to apply the material first. Okay, you need to apply the material. So you can click on the apply material here. Okay, or you just right click here and then apply the material. So either one. So you just click on the apply material. So when you click on the apply material, it will show you the list of material that have in the database of the SolidWorks. Okay, so you can use this function, or you can create create the material properties if your material is not in the list of the database. Okay, so I try to use the alloy steel. Okay, for example, this is alloy steel here, or you can have a cast carbon. You have the iron here, aluminium alloys. Okay, aluminium alloy, lot of material properties in the aluminium alloy. And you have a copper, titanium, zinc, and so on. Okay, So for this case, I just try to use the aluminum alloy or the alloy steel. Okay, in the properties table, okay, you have what you need in the mechanical properties of material. Okay, so you need to put the elastic modulus of elasticity, the Poisson ratio, the mass density, tensile strength, okay, and also the yield strength. Okay, so this is important components if you want to create a material properties of your own. Okay, and we have the properties here. Okay, because if you don't put any values of for modulus of elasticity, Poisson ratio, mass shear modulus, mass density, tensile, and yield, it will not calculate the stress of the analysis. Okay, stress of analysis. So this is important properties that you need to enter it. Okay, after you choose the mechanical properties of the material, so you need to click the apply. Okay, apply, close. So basically it will turn the color is turn to what type of material that you choose. Okay, and at the tree, okay, it already stated that you already choose the alloy steel for the material. Okay, okay. So next, if you don't have any connection, okay, if you don't have any connection, so you can left it. Okay, so the connection here, if you have any connection, so the connection basically if you click on the connection advisor, okay, what kind of the connection that you have? If you have a bolt, spring, flexible support, bearing, bonding, or weld. So if you have properties of the welding, bolt, springs, bearing, so you can use the connection here. Okay, so since this structure I don't need some connection, so I just ignore it. And then we go to the features. Okay, features. Okay, features is about if you want to put some fixed joint here. Okay, if you click on the features here, okay, we have a two type here, which is a fixed joint. Okay, fixed and also the contact. Okay, if you want to apply the fixed, it means that the part cannot move in all direction. Okay, if you apply the contacts, so it will move. It can give freely contact between the part. Okay, and also the ground. Okay, so in this case, I choose the fixed joint here. Okay, so basically in this example, okay, I want to put in this surface is a fixed joint, and I will apply the load here. Okay, I will apply the load here. So you click on this. Okay, if you right click here, you have a fixed geometry, roller slider, fixed hinge, elastic support bearing, and foundation bolt. Okay, yeah, several type of the fix. We have a fix. So fix means that you cannot allow all the part movement for all direction. So if you want to apply the roller or slider support, you can use this function. And then we have a fixed hinge. If you want to replicate the hinge joint, okay, and we have an elastic support, okay, and also the bearing features here. Okay, for this example, I want to apply the fixed geometry. Okay, you click on the fixed geometry, so it will show you what is the fixed geometry here. Okay, so I click on this surface. Okay, clicks on this surface, so it will show you this apply as a fixed joint, and then you click OK. Okay, so it will turn the icon, the green icon here, means that this surface is already fixed to the ground. Okay, to the ground. Okay, so at the right side of your screen, you have a simulation advisor, means that you already complete the study. Okay, means and then you apply the bodies and also the material. And now we are in the term of the interaction. So interaction means that you already apply the joint, fixed joint, and also next we will apply the loads, okay, external loads. So in the external loads here, okay, so you can click on this external load advisor, or you can right click here, external load. So in the external load, you have several types, which is the force, torque, pressure, gravity, centrifugal force, bearing load, and also the temperature. And we have a flow effects, thermal effect, and also with remote load and distributed mass. Okay, so you can apply the force or the torque or the pressure, okay, in this part. Okay, for this example, I use the force here. So you can use you can choose the any surface that you want to set the load. Either one, either this surface or this surface or this surface. So for example, I want to use apply the loads here on this line only, okay, not on this surface, on this line, okay. Click here, okay, but the direction of the load is not that the desired load that I want, okay. So you can choose, this is a normal direction, so you can use the, you can choose the selection direction here, okay, and you choose this surface, okay? This surface, okay, just repeat back, okay, external load force. You can choose selection direction. First, you need to choose the point or the spot that you need to apply the loads. For example, I want to choose this line, and also I choose this surface as a direction of the load. Okay, so it will create direction is a downward. Okay, and then you give the value of the loads. Okay, for example, I want to apply 200 Newton. 200 Newton. You can apply several direction in all three direction, X, Y, Z, if you want. Okay, if you don't want, you just deactivate the horizontal X and Y direction. So you just apply the vertical load. So after you apply this load, you just click. Okay. Okay, so next, okay. So if you see this simulation advisor, you already have a green tick for the study bodies material interaction. So now we want to apply the mesh. So what is mesh? So meshing is if you want to run the simulation, okay, you need to apply the mesh. Okay, you need to apply the mesh. So you can create a mesh. Okay, so this mesh density is a cost of fine. So or you want to find means that the element size, it will make it smaller compared to the cost. Okay, and the runtime is more uh, longer than cost. Okay, because it need to calculate every single small size of the machine element. Okay, if you set on the mid, okay, in the middle, so it will create this, and also you can click the meshing parameters. For example, I choose the 5 mm here. Okay, meshing elements, and then you click OK. So it will mesh here. So this is a meshing. Okay, this is a solid meshing with a triangle. Okay, triangle of the mesh. So you already have a meshing, and then you can click on the run this study. Okay, so basically before you run, you need to complete all this. Okay, you apply, you have a bodies here. Okay, you apply the material, you apply the fixed geometry, Okay, fixed joint, and also you apply the load, and the last one before you run, you apply the mesh, and after this you can run. So you click on the run. Okay, so when you see the simulation advisor, it already tick the run and also the result. Okay, so the result, so basically in the left side of the tree it already appear the result. So in this result you have a stress and also displacement, and the last one is a strain. So this is a three type of the element that you can have, you need to evaluate. Okay, the first one is a stress. Right click, show. Okay, so this is the stress of the von Mises stress. So von Mises stress, you can animate it. Okay, you right click, you can animate. So speed. So you apply 200 Newton loads, it will move the beam structure like this. Okay, and it will show the contours, the maximum stress. The maximum stress, it will show on the red one. Okay, so basically the highest stress occurred in this area. Okay, in this area, about 5.51 megapascal. Okay, Newton over meter squared, convert to the megapascal is about 5 megapascal here. Okay, okay, you can just have a okay, you can right click on the probe in order to identify the value of this area. Okay, what is the value of the critical area? Okay, here this is the value of the probe. So basically in this area the highest stress occurred compared to this area. So if you see, it's just only the minimum value. Okay, the minimum value of this stress, right? So in the mesh sectioning, you can see the cross section of the mesh. Okay, and also can evaluate the stress in this inner element of the mesh. Okay, here, and if you right click, you have a chart option here. So this is chart option. Show max. So this is the maximum occurred here. The minimum here, or maximum is here. It's not here. So the maximum one is here. Okay, and so this is how you want to define the chart here. You want to change the color, you can change it. Okay, and then we have a deform result. Okay, if you don't want the deformation result, you can. Okay, and then after the stress, you can evaluate the displacement. So this is the displacement here. So the type of the value of the maximum displacement 0.001 mm. Okay, mm, it deform. You can animate the deformation. The same, you can use the probe. This is a value, or you can change to the chart option here to see the maximum and also the minimum one. Okay, and we have a strain value. Okay, this is a strain value. Okay. So basically the strain value so the maximum one occurred here, the strain value, and also the final one. Okay, I need to show the factor of safety. Okay, factor of safety you can calculate based on the one moisture stress. So basically, you need to know what is the yield stress of the material. Okay, yield stress of the material that you already apply for this part. For example, you already apply the alloy steel here. Okay, alloy steel. So you have a yield strength. Okay, yield strength here. So means that uh, the value of the yield limit for this material is about 620 megapascal. So you need to calculate the factor of safety. The maximum stress that occurred for this part, you need to calculate the factor of safety, which is a factor of safety equal to the maximum yield stress of the material divided by maximum stress that you occurred at the part. So basically 620 megapascal will divide it into 5 megapascal, and then you can get the factor of safety for this part. Okay, basically the factor of safety is not exceed about the value of 1.2, or the maximum one is a 2. It depends on the type of the product that you need to produce. Okay, so basically it's below 1.2 is a critical one. Okay, so this is how you want to do some simple analysis here. Okay, I will show you simple structure. Okay, I will show you the next exercise, next example. Try to create a new one. We try to do some another example here. So I choose this example. Okay, for this structure, I want to apply the load here. I want to apply the fixed geometry here and apply the load here. Okay, so we go to the simulation, new study, uh, name it as a static. Okay, right click. Okay, the first step. Okay, the first step, you need to apply the material first. Apply the material. Let's say I want to apply the aluminum alloy for this part. Let's say I want to apply 6063T6, which is a aluminum alloy with T6 heat treatment. Okay, for this part we have a properties of this 6063T6. We have a tensile stress 240 megapascal and yield stress is 215 megapascal. Click on the apply, close. So basically in this example analysis 1, it's already stated that you apply the 6063 aluminum alloy T6. Okay, so in the connection, let's say I want to apply the contact. Okay, apply the contact. Since this I want to apply the fixed roller slider. Roller slider. Try to do another function. Okay, and then I will apply the external load here. Let's say I want to apply the force. in this surface, okay, change to the selection direction. I want to pull out the, okay, and then I give about -100. Okay, say 200. Click OK, and then you can click on the mesh, create mesh. So the mesh parameters is 4 mm. Okay, then you click OK. So we'll show the mesh option here, and then you run the analysis. Maybe it's not suit for the roller. Okay, you can edit the definition. You can click on the fix. Okay, you try to run back. Okay, so basically you can if the joint that you apply doesn't fit to this part, you can change it. Okay, so basically this is how you want to evaluate. I already changed this to the fix, okay, instead of the roller. Okay, so you can animate first. So basically this, you apply the 200 Newton loads, okay, you pull out. So the formation of this part will be like this, okay. So you can animate the show. The maximum stress occurred here, okay. Maximum stress occurred here. 71 displacement. So let's say I want to increase the load, okay, increase about 500 Newton. And then run back. So it will increase the stress value. Before this is about 3.9 megapascal. Now it's already make it about 9 megapascal. So the maximum stress occurred at the bottom here. Yeah, at the bottom here. And so the displacement value, and so the strain value. Okay, and you can calculate the factor of safety. Okay, so based on this, you have a 9 megapascal. You need to calculate the factor of safety based on this material. Okay, the yield stress is about 215 megapascal divided by 9 megapascal here, so you can get the factor of safety. Okay, so this is some simple example of the analysis that you can try it. Okay, I will give you some exercise to do for analysis here, and you can follow the step by step for this analysis type. Okay, so thank you very much. Assalamualaikum warahmatullahi wabarakatuh.